Hello everyone and welcome back to the workshop. As of filming this video, I'll be coming up to the 2-year mark of getting this mini lathe, and for the past year I've used it about 4 or 5 days a week. And I've seen this lathe at its best and its worst, so better lathe than ever, it's time to finally review it. So these import mini lathes have been around for a very long time, and depending on who you ask, they can really cop some flack for their size, their power, and their quality. But in the 2 years that I've owned it, I've really come to like this machine, in spite of a lot of its pitfalls. It must be said, for $600, these are amazing machines, because it allows so many people without a huge workshop to have access to a lathe, which in my opinion is one of the most versatile machines one can have access to in a workshop. Not only can it turn parts, it can also bore holes, cut threads, and if set up properly, it can be used as a milling machine. And it must be said, lathes are so much fun to work on. Now of course there are other small lathes out there, such as the US made Sherline, but the import lathes offer so much more as standard, such as the wider work area and the ability to cut threads right out of the box. Although it must be said, the Sherline is certainly in a different class of its own, and it's a much more accurate and precise machine, and it does cost slightly more than these little import lathes. Now it must be said, these lathes do get some flack due to their lack in overall mass compared to a conventional lathe. And whilst the whole lathe only comes in at about 40 kilograms, which is less than 10% of the weight of the lathe I was trained on, and by no means was that a large lathe, for most hobbyists, this realistically is the biggest thing that we'll be able to mount in our workshops, and for most plastics and soft metals, these lathes are certainly more than adequate and rigid. These lathes also get criticism because they lack the horsepower of a big lathe, but again, for most materials, you'll be fine to turn it on this lathe. The only trouble material that most of us will run into will be some form of mild steel, and these lathes are certainly capable of taking light cuts in mild steel. And to anyone who says these machines struggle to produce good and accurate parts, well, I think some of the projects on this channel should prove that otherwise. I always have a tolerance, usually of plus or minus 0.05 of a millimeter, and that's a tolerance that this lathe is perfectly capable of holding parts to. So in short, these lathes can be really great. If you have ever used a larger lathe, you'll certainly need to lower your expectations, but these can be really great, and for $600, you really can't ask too much. So with the brief overview over, let's take a more in-depth look at the lathe. So what we have here is the 7x14 mini lathe. There are many different types of mini lathes online, made by different manufacturers, some that are bigger, some of them that are more powerful, but this one here is the most common and usually the most affordable. And this one will also have several different variations. This one here is the Sieg C3, denoted by the red paint and the Sieg sticker. However, there are other similar lathes sold under the generic Metalworker, Harbor Freight, Grizzly, and they are all based on this lathe. Sieg generally will be making the castings for the lathe, and the other lathes will just be painted different colours. They will have slightly different carriages, motors, different quality control, slightly different pricing, but the quality of parts that they produce will be very similar. In Australia, the range of mini lathes is quite limited to Sieg and the generic Metalworker, so I think the Sieg one is the slightly higher quality one, which is why I ended up with this one. The mini lathe, once it's taken out of its shipping box, is about 73 centimeters long, and it will fit on most workbenches. And it can't be stressed enough, mounting the lathe to the bench using the threaded holes not only will make it produce better parts, but it is quite dangerous to have a 40 kilogram machine freely moving around, and due to the vibrations of turning, it will easily move around your workbench. Now some of you may have noticed that 73 centimeters does not equal 14 inches. The dimensions in the title of the lathe actually refer to the maximum dimension of a piece that would fit in between the lathe centers, i.e. no chuck. The lathe comes with a tailstock centre, but you would need to buy a headstock centre and a lathe dog and driver. If you did that, you could theoretically turn a piece that was 14 inches long, but turning between centres is quite impractical and it takes quite a lot of time to set it up, so most people will use a chuck of some sort. As standard, the lathe will come with an 80mm 3-jaw scroll chuck. The jaws all move together and it is great for holding round and hex stock. These are super convenient, but in gaining convenience, the chuck has cost us a good 50mm of workspace, and it only gets worse from there. When you turn long material, the part will tend to push away from the cutter. A live centre is then used to add rigidity to the piece. It's just a hardened cone in a ball bearing that fits into the tailstock, and when it's used, the work area will quickly shrink to about 260mm. And if you need to use a chuck to hold a twist drill, the workspace can be as little as 160mm long when it's fitted with a 13mm twist drill. My point being is, just because it says 14 inches long doesn't mean you can actually turn 14 inches worth of material. However, in the 2 years that I've owned this lathe, I haven't yet run into a situation where I've run out of space for turning. If you're turning material below 20mm in diameter, you can also stick the material through the chuck and down the spindle bore for extra length, although if there is too much stick out at the other end, the material will need to be supported. Likewise, the 7-inch maximum diameter part is a little bit optimistic with this lathe. With the jaws flipped, the maximum part that the 80mm chuck can turn is 80mm, and if you're using an arbor to hold the part, anything over 120mm in diameter will actually hit the cross slide, and anything above 130mm in diameter is really reaching the limit of the cross slide's travel for facing. And speaking of facing, for large diameter parts, a carriage lock is really necessary to keep the carriage locked and rigid, but in a bid to keep the cost down, these lathes actually don't come with one. However, these lathes are just so easy to improve and make modifications on, with the improvements really increasing the cutting ability of the lathe. There are so many great communities and tutorials out there, and in my opinion, the low cost of these machines really encourages you to test out these modifications. Let me put it this way, if the lathe cost 4 or 5 figures, there is no way that I would even be thinking of modifying it. Though, to be fair, if the lathe cost 4 or 5 figures, I probably wouldn't need to. Though it must be said, there is something very rewarding when you use a modification that you've made and it works really well. Before we move on, when I had the chuck off the spindle, I used a dial indicator to measure the runout or eccentricity of the spindle. Every lathe is going to have some eccentricity or runout, and the import lathe is no exception. And it's about 10 or so microns, which is a lot better than I expected after 2 years with the stock bearings. With the stock 3-jaw chuck on, the runout has jumped to about 40 microns, which I think is acceptable for everyday hobby use. 40 microns, however, may be too much for making O-ring seals or tight-fitting pistons and cylinders, and you can easily reduce the runout by buying an independent 4-jaw chuck. With an independent 4-jaw chuck, you can easily dial out the eccentricity, although it must be said it can take a while to do it if you are new to using 4-jaw chucks. And thankfully, replacement chucks only cost about $50, they're quite affordable. And as well as that, there are also scroll 4-jaw chucks, which I also own, and they are great for holding square stock, but they have the same runout issues as the stock 3-jaw chuck. One big annoyance that I do have with this lathe is the mounting system for the chuck. The chucks are held on by nuts and bolts, and the spacing to actually thread the nut onto the bolt is about 15mm. Thankfully, I rarely have to change the chucks, but since I got my 4-jaw chuck, it's happening more often than it used to, and it's a pretty frustrating and time-consuming process to actually change over the chucks. It's a small issue, but it really is one that gets under your skin. Moving on to the tailstock, this is where you're going to put your center, your Jacob's chuck, your live center, and any other tailstock tools. The taper in the tailstock is a Morse 2 taper, which is very common. Now when you buy your lathe, you'll have the option to get a lever and cam locking tailstock or a nut and bolt locking one, and 10 times out of 10, I would recommend that you go with the cam locking version. Not only is it so much quicker to lock and unlock the tailstock, but with the limited amount of space that you have on a mini lathe, usually you're going to run into problems such as the lever for the top slide is going to be in the way, which makes tightening up the bolt really difficult. And another issue I've run into is every now and then I accidentally hit the tailstock with the wrench as I'm tightening up the bolt, which actually knocks the tailstock out of line with the center of the spindle. And the biggest issue that I ran into was after a year, all the threads on the bolt completely stripped. In fact, the only reason why I have this version is it's the more common version you'd find on Sieg lathes, and it simply didn't occur to me when I bought it. Now on the bottom of the tailstock is going to be this bolt, and it's used to adjust the tailstock to align it with the center of the spindle. They do an okay job at aligning it at the factory, but it's best to check it when you get it out of the box. And once you do that, it's best to use some thread lock on the bolt to keep it in place. Next, let's quickly talk about the bed and the ways. The bed is going to be made from a grey cast iron, with the ways being ground into shape. And it represents the main bulk of weight of these lathes, and for most work, it's certainly going to be rigid enough. Unsurprisingly though, the bed isn't hardened, so you should try your best to keep the bed in as best condition as you can. You should keep the bed well oiled with an ISO 68 way oil, and keep it free of chips, and if you can, don't drop any tools on it. Now the carriage of this lathe is quite basic. We have our carriage hand wheel, the cross slide hand wheel, the top slide, and the tool post, and down the bottom we have a half nut lever. And one thing that surprised me when I first got a hold of this lathe was the lack of a dial on the carriage wheel for fine work. So any precise work needs to be done with a layout fluid and a scribe or a pair of calipers, or the top slide dial and the carriage lock. However, the top slide has a 1mm pitch lead screw, so any large work using it will be out of the question. The top slide is therefore best used for cutting angles and tapers, and on most lathes, to change the top slide angle requires the undoing of 1 or 2 nuts, but due to the limited room, the nuts are located underneath the slide, which is pretty annoying to get to, especially if you're using a dial indicator to get a very precise cutting angle. If you don't need to be too precise with your angles, there is a guide mounted on the compound, but it only measures up to 45 degrees, and for most precise work, I really recommend using a protractor, which does the job perfectly. The cross slide on the lathe is great. It's well built, it's smooth, and the gibs work really well on it. The best upgrade to make on it, to make it even better, is to replace the solid handle that is fitted as standard to one that can freely rotate. I've seen several different designs of handles with bushings, but I've just kept it simple. This is just a bolt in a hollowed out piece of plastic fitted to an acrylic wheel, and that works fine. My only complaint of the lathe is the choice of dials used. The lathe uses divisions of 25 thousandths of a millimeter on a 1mm pitch lead screw. I believe they did it because 25 thousandths is equal to 1/1000 of an inch, but it really isn't, and as a result, you need to do maths differently in your head to work out how far to advance the cross slide. For example, 20 divisions of 25 thousandths is equal to 0.5 mm of movement, which will reduce the part's diameter by 1 mm. It is a little bit convoluted, you do get used to it after a while, but thankfully there are aftermarket dials with different divisions, such as divisions of hundredth of a millimeter, which make a lot more sense. As standard, the lathe will come with a 4-way tool post, which is suited for 8mm tool cutting tools. And whilst it isn't essential, I really recommend replacing it with a quick change tool post. It allows you to quickly swap in and out different tools, and it allows you to use tools that are up to 12mm in height. So let's talk about the lead screw. The lead screw runs off the spindle via a gear train. The lathe comes with a chart and a set of spare gears, and the ratio of the gear train that you use will determine how far the carriage will move with every revolution of the spindle. This is used for cutting threads in a workpiece. I use these carbide threading tools, and they have cut into plastic, brass, aluminium, and fine pitches into steel with no issues whatsoever. The threads are quite accurate on this machine. I've never had any issues with them, but due to the large amount of current required by the motor to cut the threads at low RPM, deep cuts will cause the motor to quickly stall. Personally, I stick to using pre-made bolts or threaded rod, since factory-made bolts are a lot stronger due to the work hardening due to the forming process of threads. And if I ever need to cut bolts, I try to stick to using a tap and die, but if I have to use the lathe, I will use the lead screw, and the results are pretty good. The big advantage for using the lead screw to cut threads is you can easily make non-standard threads. For example, I needed to quickly make a M6.75 by 0.7 tap, and that was very useful. And I also needed to make left-handed threads, which this lathe can also make. Another issue with this lathe is that it doesn't come with a threading dial, meaning you have to reverse the lathe, keep the half nut engaged to keep the tool cutting in the same groove. Now this lathe uses acetal gears, which is fine for light use, but if I was to use this lathe often for cutting threads, I'd opt to buy a set of metal gears. Acetal is fine, but they certainly can crack under heavy loads. The mechanism for holding and aligning the gear train also leaves a lot to be desired. To get good meshing gears can be pretty tricky, and it would be very annoying if you needed to swap gears in and out quite often. Now, a topic with some contention is, do these lathes have a power feed? Well, yes, but actually no. Look, the lead screw can be used as a power feed. Many people do it, I've seen it, I've used it a few times. However, in most circumstances, on most materials, it's just too fast. The feed of 0.4mm per revolution is the slowest you can get, which is 400% faster than the feed on the lathe that I learnt on. And the motor just doesn't have enough grunt to do any practical machining at any practical depth using this feed. And furthermore, most lathes will have a separate power feed and drive shaft with separate ratios to the pitch and lead screw, and use a drive box in the carriage to drive the feed. This is done so the lead screw isn't worn down over time. And that's my biggest issue. The lead screw and half nut is going to produce quite a fair amount of wear on the lead screw, and once it wears down, the lead screw is probably going to be out of whack. It isn't designed to be used as a power feed. If you use it as a power feed every now and then, I'm sure there's no issue with it, but if you use it as a power feed all the time, you're going to get a fair amount of wear. Next, let's talk about the motor, because this is the area that's going to see a lot of deviation between the types of mini lathes. The Sieg C3 uses a 350 watt DC brushed motor with a high and low gear selector, and I've seen lathes of this design come with a 400 watt, 500 watt or 600 watt motor. Some of them have high-low gears, some of them are brushless, some of them are brushed. There is a lot of variation. And generally speaking, the DC motors that are used have some big advantages. For one, the variable speed drive controllers allow them to easily change the RPM with the use of the dial on the front, and the motors are quite compact but still powerful, And even though it's only a 350 watt motor, because of the high-low gear selector, you're going to get a fair amount of mechanical advantage, which means this lathe can surprisingly cut a fair amount more than you would expect from a 350 watt motor. However, it's generally accepted that you might need to sacrifice the correctly calculated or optimal surface speeds to get a decent cut in some harder materials. DC motors have great torque at low RPM, but they have really bad efficiency due to the back EMF. And at low RPM, the motor requires a large current, which the control boards simply can't supply, so they simply trip and stop when the current gets too high. For this reason, you do need to run the lathe at a higher RPM to get good motor efficiency. That's why when I turn metal, I tend to turn at a higher RPM, so the motor is running more efficiently than it would be at lower RPM. In doing this, I do tend to produce a lot more heat than I normally would, and I do sacrifice the tool life a little bit, but that is the compromise for having a small motor. Next, let's talk about the quality of parts that this lathe can produce. And in my opinion, the quality of parts can be plotted on a graph, and it will go up with respect to how much effort you put back into the lathe, though the more that you put into it results in diminishing returns. Here's what I mean. From the factory, these lathes are assembled, but they aren't really what I'd call precise. What you need to do is you need to adjust the gibs because they tend to be pretty loose, and same for the retaining strips on the bottom of the carriage. The backlash adjustment needs to be tightened in on the cross slide, and the adjustment on the tailstock needs to be dialed in too. If you do these small steps, the quality and repeatability of the parts that you get from the lathe will go way up, but the amount of effort that you put in isn't too great. Other improvements, such as replacing the gibs altogether, lapping the bedways, will also improve the quality, but the improvements to the parts also increases. Although I'm not saying that they aren't necessary, what I'm just saying is the quality that you get out of the box isn't definitive of what you can get from the lathe. Finally, let's talk about reliability, because reliability is a problem with stuff that you get from import machines. So first of all, it must be said, the quality that I get from this lathe is certainly not definitive of the quality that you might get from this lathe. The quality certainly does vary. And that's just a trade-off that you need to accept when you're buying a $600 lathe. The best thing that you can do is buy from a reputable importer with a good warranty. But in terms of the lathe itself, there really isn't all that much to go wrong with it. I mean, there's very little on this lathe. I did mention the threads stripping out on the tailstock earlier, and that was an easy fix. And a giant chunk is missing from the tailstock handwheel, though it is my fault because I did drop it, but there really isn't all that much to go wrong. One thing that a lot of people do suggest is to replace the bearings in the housing with tapered roller bearings, and whilst it is something that I probably will do in the future, like I said earlier, I have had very little issues with the machine, and after 2 years of use, the run out on the spindle is less than 10 microns. Though I guess I am glossing over the elephant in the room, and that's to do with the electronics. The Chinese power board on my lathe blew a resistor and it took out the whole board. And this occurred during threading when I needed a lot of current at low RPM, and I think a current surge when I started threading took out the board. And for such an inexpensive lathe, the circuit boards are actually quite expensive. They were something like $200 Australian, so instead of replacing it, I've gone and replaced it with an AC motor, which has a lot of benefits, which I will have a video on sometime soon. But overall, the circuit board is not a huge issue. Yes, it has happened to other people, but it's not something that is really common with people with these mini lathes. Overall, I can say I am really happy about owning this mini lathe. Through the highs and lows, I can say it's been a total blast to have machined on it. If these things didn't exist, I probably wouldn't have gotten a lathe at all. It fits in my small workshop and it really punches above its weight. Sure, it does have limitations, like it can't cut all that much steel, but it really doesn't matter. I've had a lot of fun on this, they are really worth it. And with that, I hope you enjoyed it, hope you learned something, Thank you very much for watching.